My name is Krishnaik and welcome to my YouTube channel. So guys, today in this particular video, we are going to actually create a deep learning project completely from end to end. And this will be super helpful for the beginners who are actually getting into deep learning techniques. The reason is that the model that we are going to use is a transfer learning model, so that you don't have to worry much about the accuracy. And with the help of that particular model, and that specific model is VGG19, which you can see over here in the screen, which I've written in these 3 steps. We'll try to download this VGG19 model. We'll try to download the weights, and then we'll try to use this model to classify 1,000 different classes. You'll be seeing all those kind of examples as we go ahead. So over here, we are going to include 3 steps. One is create VGG19 model for classifying ImageNet images. Then we'll try to create a Flask app to upload the image, because for testing, right, we first need to upload the image, and then we'll try to predict that specific image itself. So what we are going to do is that, and after that, we are just going to predict from the Flask app with the images that we have actually uploaded. So after uploading the images, we'll go and hit the model, and then we'll get the result, like what label it actually belongs to. Now remember guys, you can also start coding with me, because I'm going to show you completely this from scratch. I'll just write all the code over here in front of you, and then you can also follow that and you can also implement that. Anyhow, the link will actually be given in the description of this particular video. So let's go ahead and try to do this. Now before that, you need to know what is ImageNet images, guys. So let me just go into the Google and just search for it. Suppose I search for ImageNet dataset, okay? And when I search for ImageNet dataset, if I just go and click on images, you can see that there are a lot of images with respect to ImageNet, and this images basically belongs to 1,000 different classes, okay? And when you see advanced transfer learning techniques models like VGG19, VGG16, you have ResNet 50, and you have other models. So if you want to really see how it looks like, you just go and search for Keras VGG19. So here it is. You just go and see in Keras application. This many transfer learning techniques are there. Exception, VGG16, VGG19, ResNet 50, ResNet 101. You can implement any of this. And remember, all this particular model will be able to classify 1,000 different classes. And you can also use this as a transfer learning technique. Skip the last part, and then you can add that how many classes you want for your specific model or your training purpose. You can do that, but we'll try to see that in the later purpose, because this is, as I said, for the beginners. We'll try to create this from scratch so that you will also gain some kind of confidence, so that you can implement the future complex deep learning technique models. Okay, so what I'm going to do over here is that for creating the VGG19 model, guys, right now I have TensorFlow 2.0 installed. Okay, so if I have TensorFlow 2.0 installed, Keras is basically integrated within that. Okay, if you don't have TensorFlow 2.0, I'll also tell you how you can download the VGG19 model. So let's go ahead and try to, first of all, import a library. Now, before that, I will just go and search for TensorFlow 2.0, Keras VGG19. And here you will be able to see that this is basically my library that I'm going to use. From tf.keras.application, I'm going to take this VGG19. Okay. So for that, what I'm going to do, I'm just going to write from TensorFlow.keras, and remember guys, this is specifically for TensorFlow 2.0. okay, .applications.vgg19. okay, you can take VGG16 also, it is up to you. I would suggest that I'm doing it with VGG19, you do with ResNet. Okay, you do with VGG16 if you want. Then I'm going to import VGG19. So here it is, I have imported this. Okay, now in order to download that particular model with the weights, the VGG19 model we are going to use, so we need to download the weights, right? And these weights are already present over here. I'm just going to use these all parameters. Okay, so for that, what I'm going to do is that, first of all, I'll create a model, and inside this particular model, what I'm going to do, I'm going to initialize my VGG19. Okay, and here I'm going to specify some parameters. Where can I look at all those parameters? The parameters present over here include top is equal to true. That basically means I'm going to take the whole network. Okay, the weights is equal to ImageNet. Please make sure that you use this particular parameter, guys. It is pretty much important, because then it will download all the weights that are responsible for classifying those 1,000 classes, right? So it is required. So by default, all the default parameters we are going to take it, because since we are actually solving the ImageNet classification problem. So what I'm going to do is that I'm just going to take this particular parameter just to showcase. Otherwise, if you don't take, that is also fine, because just to show you that I'm taking ImageNet parameter. By default, all the remaining parameters will be same. as we had seen in the documentation. Now I'm just going to execute this. So if you are executing for the first time, guys, it may take somewhere around 10 minutes because it will be downloading the whole weights. It is a huge file, VGG19. Okay, it will be downloading from the TensorFlow storage Google APIs over there. You'll be able to see that. I'll just show you how it looks like, you know. So for the first time, when I was downloading, it was downloading it from this particular URL, you know, from this particular API itself. You can see it was downloading the weights, right? So for the first time, if you're downloading it, it will probably take around 10 minutes. It depends on the internet speed that you have. Now, fine, I have actually created my model. Then I'll just write model.summary. Okay, so here is my model.summary. This will actually show you, okay, it has 19 layers, and you can see that the last layer is able to classify 1,000 different classes, because there it has 1,000 hidden nodes, you know, the neurons basically. So this will able to classify 1,000 classes itself. So pretty much simple. We have just written 3 lines of code. We not had to train it completely from scratch. We just use the transfer learning techniques, which is having a very good accuracy when you are trying to classify 1,000 classes. Pretty much amazing. Okay. Now next step, we should always know that, guys, we need to save this, right? We need to save this particular model so that we can actually use this when we are actually implementing our Flask app. Okay, so here we have over here, I'm just going to write it as model.save. Let me see how can I write this. VGG19.h5 file. We'll try to save this. Okay, so this will probably take some time to save. Let's see whether it has saved or not. In the same working location, I'll just go and see. Here I have VGG19.h5, right? So this is where I have actually created my model. My model is ready. Okay, now I have to consume this model into my Flask app. Okay, the Flask app that I'm actually creating. And that Flask app, I'll try to create that in my Spider IDE. So let's go ahead and try to bring my Spider IDE. And before that, I really want to show you the folder structure, what all I have created. And then we will try to solve this particular problem. So let's go ahead. So here it is. Okay. So we are over here. What I have done is that, guys, you can also see the folder location. Okay. So here, my folder location, this untitled.ipynb was basically my pynb file. You can see over here on the right hand side. Probably it looks smaller, but just try to visualize it. Anyhow, my code will be visible pretty much better. Okay, so here I have some folders. Okay, one is static and one is template. I'll not show you how you have to create the base.html or index.html, because I've just taken some basic look, like, you know, where I'll be able to upload the images and where I'll be able to predict. So here I'll be having one static image, one template image, and I've actually created one uploads folder. Okay, now inside this uploads folder, what happens is that whenever I upload or browse anything in front of my web app, it will try to upload that inside this upload folders. Okay, so I'll just tell you when I'll be actually running it. Okay, and then I've just created one app.py. Now in app.py, guys, remember, I'm just going to show you some of the things over here, which is pretty much important. Let me just show you. Okay, guys, so let's go ahead and try to develop this now. I have imported some of the important libraries that I required. And remember, this will be working for TensorFlow 2.0. I have imported NumPy over here because I'll be requiring NumPy, because the images that I upload, I have to convert that into arrays. So it will be very, very helpful for us when we are doing this. Okay, and then I have also imported image net underscore utils, process underscore input, decode underscore prediction. We'll just go step by step. For initially, what I've done is that I have imported load underscore model and I have imported image. Let me just begin with this. Don't worry about this right now. Okay. So over here, I have imported 2 libraries. One is load underscore model and this one. And then I have imported some of the Flask library like Flask, redirect, URL for, request, render underscore template. These are pretty much required. And this is the basic skeleton of the Flask app, which and probably you'll require all these particular libraries initially. And then I've given the definition of my Flask app over here as app is equal to Flask underscore name underscore. And then if underscore name is equal to main, I'm just saying that, okay, run this particular app in short. Okay. Now, the next step, what I'll do. First of all, what I'll give is my model path. I'm going to give my model path. Let's see. My model path is nothing but I have to just give my model path with my model name itself. So let me just zoom in a little bit so that will be helpful for you. So here I'm just going to write it as VGG19.h5. Okay. So yes, I've written VGG19.h5. Let me just remove this quotes. I'm just trying to use single quotes. I don't know why it is getting added as double quotes. Okay, pretty much simple. I've given my model.path. Always remember, guys, my first step is actually to load this model, right? We need to load this particular model itself. So for that, what I'm going to do is that I'm just going to write this comment and say that load model. Okay. And remember, we had imported the library which is called as load underscore model. And here I'm going to take it as model is equal to load underscore model. And I am just going to give my model underscore path. Pretty much simple. I hope we have followed everything perfectly and there is nothing to as such as worry, because we are able to just load the VGG19 model, which is the first task everybody has to do. Everybody has to do, right? So we are going to upload this particular model, and then after loading this particular model, if you want to make the prediction, we have to use something like model underscore make. And remember, guys, this function is only useful when you are actually trying to, and this is an inbuilt function. Remember, for ImageNet, every types of model that you use, you have to use this particular function. Okay, otherwise it will be giving you an error, because that is how they have created. But if you are creating your own custom, model, at that time you don't require this particular function. Now let's see whether it works or not. So first of all, I'm just going to import this all things. Okay, so I'm just going to execute this line by line. Remember, you can see over here it will get executed. It is getting executed. Now what I'm going to do is that I'm just going to execute this 3 lines of code and see whether it works fine or not. Okay, it says that it does not have no attribute as underscore underscore make underscore underscore prediction. It's okay. Probably there are some of the mistakes that we have done. And remember, guys, I'm showing you this particular mistakes because you may also do this particular mistake, right? And the major mistake over here is I've written double underscore. So sometime it happens. So what I'm going to do is that I'm just going to execute this. Okay, it works fine. Okay, but it is saying that the model was not compiled. Compile it manually. Okay, fine. Don't worry about that because it will get compiled automatically when we are running the code. Okay, so we have done this. Pretty much simple. Now the next thing is that we'll try to create an inbuilt function. We'll try to create a function, and this function will be actually responsible in converting the images into some kind of array. Okay, guys, now I hope this is working well. Now in my next step, what I'm going to do is that I'm going to do some pre-processing of that particular image. And for that, I've actually created some function. You can see over here, it is basically like model underscore predict. Here we give my image path and then we give the model. Now, first step over here, what it does is that, and remember guys, I'm just going to remove this particular library also because we will be requiring process underscore input. So remember, let's try to understand what this function does. So inside this function, we are first of all giving our image underscore path and model, and then we are just loading this image. And remember, the target size that you are actually giving is 224, 224. Remember this, because I'll tell you why. By default, when you are implementing some transfer learning techniques like VGG19, ResNet, VGG16, the target size of the image is given as 224, 224. Okay, so this is pretty much important. If you give some other size, it won't work. It will give you a lot of error. Okay, so first of all, I'm loading the image from the image path, and by making this as a target size, then in the next step, I'm converting this image into an array. Okay, converting an image into an array. Then what we do is that we are expanding the dimension. Okay, we are expanding the dimensions of that, and this is required in the pre-processing input. If you execute line by line, you'll be able to understand that, because in the image you have to expand the dimension so that it can be given as an input to your model itself. Then finally, what I am going to do is that I'm just going to remove this comment so that you don't worry about anything. So now what I'm going to do is that I'm going to just pre-process that particular image itself. And finally, after we have done this, we just write model.predict. This model is nothing but the same model that I'm actually giving. So as soon as I get the prediction, I'm going to return this particular prediction. So this particular function, what it does is that it just takes the image, it does all the pre-processing required, and finally it does the prediction and returns the prediction back. So this is what this particular function does. Pretty much simple. Okay, now what I'm going to do is that we have created the pre-processing function already. So this is basically my pre-processing function. So I'm just going to give a comment over here, pre-processing function. I think we are just doing it step by step in a proper way. Now what I'm going to do quickly is that I am going to start my Flask thing. That is basically I'll create an app route. Now inside my app route, first of all, I'll give my root folder. My root folder should be doing anything, right? So here I'm just going to give this as my get method. Inside my get method, by default, I'll be uploading my home.html or index.html, right? That you should remember. So this is basically a get method, my app.route. Now what I'm going to do is that I'm just going to create my function saying that, okay, this is my index function, start page function, something like that. You can give your own things. And then I'm going to return my render template. Now render template is pretty much necessary, guys, because this render template will be responsible for showing your the first starting page, okay, that HTML page which you have actually created. So return render template, and here I'm going to give some parameters over here, which is my HTML page. Now HTML page, what I am going to give over here is, guys, index.html, the index.html that I've created for this specific purpose. So this is my index.html, okay. So this, what I'm doing with my help of the root page, whenever I just type slash, right, along with my URL, it is going to display the index.html. Now index.html will basically have an UI which will help you to upload an image, okay, over there. Just like a browse button will be present over there where you can actually upload your image. Okay, fine, this is done. Now in the next step, what I'm going to do is that I'm again going to create my app route, because now I need to do the prediction. So app route, over here it will be slash predict. Pretty much simple. This is the function that I'm actually creating for this, because not function I'll say, but the URL. If you write the localhost slash predict, then it will go and hit this particular function itself, right? So here my method is actually, okay, my method should be having both get and it can have post. Okay, so this is done. Now in my next line, what I'm going to do is that I'm going to create a function which says definition upload, because here I'm going to upload that image. And then if I write if request, and remember guys, I hope I have uploaded request somewhere. Okay, let's see. Okay, I have uploaded the request. So if I write request dot method is equal to post. So I'm saying that if it is a post, if we are trying to post it by uploading an image, that basically we come to know that, okay, from the front end, the user is actually trying to post an image, right? He's trying to give an image and he's telling me to predict that, right? So what I'm going to do is that I'm just going to get the file from the post. And this is specifically your image file, okay? So in my next step, what I'm going to do is that I'm going to just quickly say that, okay, fine, you're posting an image right from there. So what I'm going to do is that I'm going to just write f is equal to request dot files, and this variable name that you will be seeing will be file. Okay, how I'm saying it, just go to the index.html, guys. In the index.html, you can see that this is the input where you will be uploading the image. Okay, and it can accept a PNG, JPG, and JPG. And here the name of this particular input is basically file. So I'm trying to upload or get that particular file in my post in the similar way. So you have to write file over here. If you write some other variables, then you also have to write some other variable over here. Okay, the name of the variable. So fine, this is done. Now what I'm going to do is that I'm going to first of all save this file to my upload folder. Remember, I have created an upload folder over here. So I'll be uploading that file first of all over here itself. So for that, what I'm going to do is that I'm just going to write this basic function saying that base path os.path.directory name with file. Now remember, we are using OS. So what I'm going to do is that I'm going to use some of the libraries before going ahead, and some of the libraries will be like this OS, operating system, glob, and regular expression. I'm going to use some of the libraries like this, and here you can see that I'm using this OS, right? So here I have actually given my directory name as file underscore underscore file. Now still you may be confused that Krish, this underscore underscore file. Okay, so here I'm actually getting this particular file name, and this is basically my base path. Now, still I need to save it, right? I've just got my base path. So for that, I'm just going to write another 3 lines of code, which looks like this. I'm saying that os.path.join base path with uploads. So if I just see this base path, this will just give me the root path of this particular working location, you know. And then I'm actually joining with uploads, and here you can see secure.filename, f.filename, and finally I'm saving that particular file in this particular location. It is a simple code. What it is doing is that we are taking the images, we are saving that into uploads folder. That is what, in short, we are actually doing by writing this 4 lines of code. Now, after this, what we are going to do is that, guys, we are going to make our model prediction. We basically have to call this particular function, that is model prediction, guys. This particular function, sorry, model predict. So what I'm going to do is that quickly I'm going to say here we make our prediction, so that you also understand whatever I'm trying to say over here. Okay, now for making this particular prediction, I am just going to create my variable like this, and I'm going to call my function, that is model predict. And inside this, remember guys, 2 things that we have to give. One is file underscore path. So let me just give my file underscore path over here, and the second parameter is basically my model. Okay, the model I have already uploaded over here, right? I have taken this particular model. Perfect. So I have done this. After doing this, guys, remember, I just have to, you know, that after this model predict gets executed, I'll be getting some predictions, right? And the predictions that we'll be getting, you know, we have to read those predictions. Okay, read those predictions. And before reading those predictions, remember, whenever we are implementing by using transfer learning, we also have to decode those predictions. Okay, we have to decode those predictions. Now, first of all, I have my prediction over here, right? And for that, what I'll do is that there is something called as ImageNet decode, and this is also available in Keras, guys. So remember, the next parameter that I inserted over here, or next library that I actually imported over here, is decode predictions. Now what I'm going to do over here, as soon as I get my prediction, I'm going to use this decode prediction, and this will actually convert whatever class we are actually getting, you know. And this decode prediction basically means that whatever class that I am getting from this particular function, right? From here, I'll be getting one kind of class. It may be 3rd class, 4th class, because there are total 1,000 classes. And this decode prediction is another library which will actually help you to map those class with the name of the class. Okay, that is what it is basically used. And this particular library is actually present in the ImageNet underscore utils, right? So remember, for with respect to ImageNet, that is how the mapping takes. Now remember one thing, in model predict, I am giving you the class label, right? I'm giving, the model is giving me the class label. After I get the class label, what I do is that I pass through the decode predictions, and then it will map that class label, sorry, not class label, class index to the class label. Okay, so remember again, guys, I'm going to repeat it. Model underscore predict will give us the class index, okay, which class it belongs to, and then my decode underscore prediction will map the class index to the class label, right? And finally, we'll get some predict underscore classes. And finally, when I say that result is equal to, when I try to convert this into string, then, and remember, you have to take the 0001. Okay, this location will be having the name of that particular class. So I will basically get my result. Now, after I get my result, guys, what I'm going to do is that, you can see over here, I'm just going to write over here, I'm just going to return my results. I'm going to return my results, and after that, I'm just going to say return none, so that I don't want to return something back, but instead this particular way uploads will actually then display it over there itself. Okay, just try to see this. Now when I will actually be returning, and remember, this return none is for, suppose if this is not a post method. Okay, let me just see whether this is correct or not. It belongs to column 5. This belongs to column 5. Perfect. I still get one error saying that request.method. Okay, it will be double equal to. Okay, so here I'm actually using double equal to. Okay, so secure underscore file name. It works fine. I think this is some kind of error. Undefined name secure underscore file name. I think I have to import this particular library also. So for that, I am going to use one library which is called as like this. Okay, so this particular libraries we have to use, which will actually help you to secure the file. Perfect. Now, okay, this is spread, not spreads. Okay, pred. I'm getting the pred decoding. Okay, perfect, guys. Now see what all we have done. We have actually started the app. Okay, I've created two. One is index, one is upload. Index is basically my home page. Pretty much simple. It is my home page. Inside this index, there will be a browse button where I'll be uploading the image. As soon as I upload the image, click the predict button. Now see this over here. We have something like predict, I guess. See this. This is the button predict. Okay, this is the button predict. When I click that, automatically it will go and redirect over here /predict. Okay. When I do /predict, it will go and hit this upload function. It will take that image, save that image inside my uploads folder, and then we'll make a prediction. By the prediction, we will be getting the index of the class, and then by using this decode underscore prediction, we will try to convert that into a class name. Okay, so that is what decode prediction does. But remember, we have to take this particular location. You can explore this, and finally we'll get this, a simple way of actually creating a wonderful app. Okay, guys, now to verify whether everything is working fine, we are just going to our Anaconda prompt and we'll try to execute this and see whether it is working fine or not. So first of all, just open your Anaconda prompt, go to the same working location where you are actually creating this particular file. I've just gone into my same working location and just I'm going to write Python app.py. Now here you can see that I also have a GPU in my laptop, so you'll be able to see this kind of things. But if you don't have a GPU, will not be getting all this kind of messages. Okay, so yes, it has run successfully and it has been running in this particular local host. Now what I'm going to do is that quickly I am going to what I'm going to do is that you can see my Anaconda prompt over here. Now I'm going to quickly go and execute this particular IP in my browser. So I'll just say this one. Now here you can see that as soon as I do this, my root index.html is this one. Amazing, it looks fine. Now what I've done is that I've copied some of the images, guys. What I can do is that you just go to choose folder and just select one of the images. So I have inserted 3 images, like one is of a bird, one is of a turtle. So let's start with pandas. So when I go and select pandas, if I do the prediction, oh, it's amazing. You know, it is giving us giant panda. Similarly, if I just go and try with tortoise, then it will just go and do the prediction. Pretty much amazing. You can also try with this particular image, and if I do the prediction, beat. Okay, it's amazing. You can also give you can search for any other images if you want. Just try to do this, and you'll be also able to implement it. So in short, guys, you could understand that just by writing 4 lines of code, I was able to create this particular file, that is the H5 file. Then I went to my Spider ID. I made this particular folder structure, and remember, all these particular files will be given in the GitHub link. The link will be given in the description, guys. Just try to implement it. Now you will be considering, Krish, what if I want to create my own model? That also will do it, guys. We will be doing that completely from end to end. We'll try to show it to you. What you can do is that if you don't have GPUs, you can actually run that in Google Colab. But if you really want to, again, if you don't have that also, and if you know coding, you know how to create your models. So you can also use Teachable Machine. In Teachable Machines also, you can actually create your models quickly, image classification models and all. Over here, you have audio projects also and open pose also. So image projects also you can create. Just select the image projects, like just put your faces, somebody's faces, and just try to download that H5 file. Once you download the H5 file, you can also be able to import that H5 file inside your Spider ID, right? Like how I have imported it over here. So just try to do this by yourself. But in the upcoming videos, I'll be trying to show you some of the models that you can develop by using convolution neural network completely from scratch. and then we'll also try to do that in the same way by putting it in end-to-end manner, so that will be shown you in the upcoming classes. So yes guys, this was all about this particular video. I hope you like it. Please do subscribe to the channel. And yes guys, we are pretty much near to 200k subscribers. Thank you for all the support and love. I'll see you all in the next video. Have a great day. Thank you and all. Bye bye.